Number 4 says that you have 5 friends, but you can only pick 2 to go with you to a birthday party. So there's 5 people, but we can only pick 2. So 2 that are going to get picked, and then 3 that are not going to get picked. So the question is saying, how many possible choices do you have? Well, so I've just made up some names down here at the bottom. But so if we said, well, who are 2 people? Well, I could do Joe and Eddie, right? That would be 2 of the 5 that I could pick. Or maybe I do Joe and Liz, right? So that would be another possible pair of people that I could pick. But where this is a little bit different than what we've been doing is this is an example of a combination. So it's an arrangement, because we're picking 2 out of some large number here, 5. But it's an arrangement where order does not matter. So that's the difference here. A combination is an arrangement of objects where order does not matter. So the example I use here, for instance, is a pizza. If you wanted jalapenos, black olives, and pepperonis, when you call up and order that pizza, it doesn't really matter the order you tell the person on the phone the toppings you want, because you're going to get the same pizza. Likewise, it doesn't matter how they sprinkle it on there, because again, you're going to get the same pizza. So again, order does not matter here. Order does matter, again, with a permutation, something like a password, your lock here, but here order does not matter. Now, we're not talking about pizzas in this problem, we're talking about people. Well, why order doesn't matter here either is that if I said, hey Mom, well, I want Joe and Liz to go with me to the party, if I say Joe and Liz, that's the same thing as saying Liz and Joe. It's the same 2 people. So it doesn't really matter the order that I invite those people, because it's the same pair of people. So we're asking the question here, how many different pairs of people could you come up with? So once you've established a pair, it doesn't really matter the order that you put that pair in, because Tony and Eddie is the same thing as Eddie and Tony. Now there's maybe kind of a long way we can think of this, and then we'll kind of look at the short way of looking at it. But if you didn't know any other kind of fancy math ways to do this, you could just kind of start out a list, and we could say, well, let's say Sarah and Eddie, or we could do Sarah and Tony, Sarah and Liz, Sarah and Joe, right? And then I can go to Eddie, and I could say, well, what about Eddie and Sarah? Well, I couldn't count that because I've already counted the 2 of those people, so that wouldn't count. But I could say Eddie and Tony, and Eddie and Liz, and Eddie and Joe. And then I'm going to go to the next one. So I could say Tony and Sarah. So Tony and Sarah, but I wouldn't count that one because I've already got that pair right there. And then I could say Tony and Eddie. Oh, but wait, I've already got that one right there. Now I could say Tony and Liz, that's a new pair of people. And Tony and Joe, that's a pair that we hadn't talked about yet. And then if I said Liz, so if I said Liz and Sarah, well, again, I've already got Liz and Sarah right there. If I said Liz and Eddie, nope, already got them. And then if I said Liz and Tony, oh, well, I've got that one right there, right? I've already got those 2 pairs of people. The only new pair would be Liz and Joe. I haven't mentioned Liz and Joe yet, right? And then if I go to Joe, I've already done Joe and Sarah, right? And I've already done Joe and Eddie, right? Because Joe and Eddie would be that pair right there. And then Joe and Tony, well, I've already done those 2 because there's Tony and Joe, right? So those are, I would be counting them twice. And then I've got Joe and Liz, which I've just got right there, right? So you notice what ends up happening is that you thought maybe I would have had, what I got here, 1, 2, 3, 4, 5, 1, 2, 3, 4, right? You would have thought maybe I've got 20 different possible pairs, but again, I would be counting some of those twice, so it ends up really being kind of half of that. So we're going to see that our answer is going to end up being 10. Now this works when there's not that many different possible pairs. If we were picking from 500 or 5,000 people, we wouldn't want to do this. We'd want a more efficient way of doing it. So what you're probably thinking, and the mistake that a lot of people make, is they say, oh, okay, well, I got 2 friends. Here's my first friend, and here's my second friend. And then I've got 5 people to pick from, and then once I pick one of those people, now I only have 4 left. Oh, so my answer should be 20. Well, again, the thing about that is that that would not be correct, right? Because that would be as if if it were a permutation, but it's not a permutation. The order does not matter. So what we end up seeing this is that we're going to take, and you'll notice on the bottom right there, there's some new notation for us here. So the notation for a combination is that we're going to say how many people are we picking from. So the out of. So out of 5, we're going to choose 2. And so the total goes on the top, so 5 factorial, and then what you pick and what you don't pick. And the reason why we're dividing here is because we're saying that we have less than if it were a permutation, right? So, so the idea of dividing, we're making smaller. And so a couple different ways we could do this. We could go straight into the calculator with it. We could also, the way to do it without a calculator is, the factorial means that you just write it all out. Get that out of the way. So 5, 4, 3, 2, 1. 2 factorial would be 2 times 1. And then 3 factorial would be 3 times 2 times 1. And then we can do some canceling. Right, those cancel. 2 goes into 4 twice. And then so what's left over would be 5 times 2, which would be 10. Which is what we said here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 pairs of people that we can invite. Alright, so go ahead and pause now. Or actually, before we stop here, let me just show you how you would do that in the calculator. If you wanted to, if you didn't want to write all that out, what you could do is you could say 5 factorial divided by, and since we're doing 2 things on the bottom, we'll put parentheses there, 2 factorial, and then 3 factorial. And then close that off. And then so we get 10. So that would be the alternative if you don't want to kind of do it out by hand that way. Last thing we'll do too that I wanted to label here again is that the top represents the total. So there's a total of 5 people. And then on the bottom, it's what you pick. So we pick 2 people, and what you don't pick. So there's 3 people that we didn't pick. And so the 2 numbers on the bottom will always add up to the top, right? Because what you pick and what you don't pick will always add up to the total. Alright, so let's go ahead and stop here, try number 4 on the right, and then we'll move on to number 5.